Page 31. We can also solve a system of equations by adding them. Now the key for adding them is understanding what an additive inverse is. An additive inverse is two variables that share the same coefficient but have opposite signs. That means you look at here, the same variable, and the coefficient is 2, that's the number in front of it. They have the same, if they're the same variable and they have the same coefficient, plus, for a third thing, is that they have opposite signs. This is positive, this is negative, then these are additive inverses. And these are going to become very valuable in the steps we're about to do. So, now that we understand what an additive inverse is, we can apply it to solving this left bracket, this system of equations. Notice that the additive inverse in this case is pretty much the same here. It's got the coefficient of 2, the variable of y. This also has 2, and this has y. They have opposite signs. Did you notice? That's going to come in handy because all you're going to do is going to treat this like a basic addition problem, and you're just going to add everything together. So just pretty much put a line like that. Just add the top to the bottom. So this to this equals 2x, there's 2 of them. This whole thing, positive 2y plus a negative 2y, it just comes out to 0. And then over here, this is 12, because 12 plus 0 is 12. So there you have it. You just eliminated this variable. We have it in terms of x. Now let's go ahead and solve it. For x, we're going to rewrite it to make it look a little bit nicer. Go ahead and divide by 2 to isolate y. It becomes y equals 6. Now that you have this, we're going to check our work. Actually, before we check our work, we have to solve y. We only have one data point in our ordered pair. We need to find the other variable y. So let's go ahead and plug 6 back into, let's go to the top equation. So this is, I'm going to write it right below it. So x, oh, I already wrote it wrong. This is supposed to be a 6. We're going to plug in the 6, remember? So 6 plus 2y equals 12. And we're just using this top equation up here, and we're plugging in our 6. We just solved for x, and we're just plugging it in, subbing it in, substituting it in. Let's go ahead and solve for y. Subtract 6 from both sides. We're going to be left with 2y on this side and then 6 on this side. Let's isolate the variable by dividing by 2. These cancel, and it becomes y. 6 divided by 2 is 3. Y equals 3. So now we figured it out. We have x is equal to 6, y is 3. Let's write it out in ordered pair form, which is parentheses, the x variable first goes, that's a 6, and then y, which is 3, and then close parentheses. So let's check this, last step, of course. So let's check it with the top one. Or let's switch it up, let's do the bottom one actually. We'll check it with the bottom one. So 6, we're substituting in for x. So 6 minus 2 times 3. 2 times 3, because we're substituting the 3 in for y. This is all supposed to equal 0. Let's see, does this actually come out to that? Well, 6 minus 2 times 3 is 6. Okay, 6 minus 6 is 0. So it indeed checks out. There's your solution right there. Remember, additive inverses up here, same variable, same coefficient, but opposite signs. Those are the key to adding these to solve the simultaneous equations and finding the common solution.